Welcome to my class on swords. In today, I shall be discussing swords and so many subtopics under swords. So let us begin. The first thing I'm going to be telling you that is needed in understanding swords is just a summary about numbers. So what I'm going to tell you is that numbers are categorized basically into two. Okay, so a number system generally is categorized into two broad types of number systems, and under numbers we have numbers that are called real. If a number is not real, it is what? Complex. Okay, so we have the complex number system and we have the real number system. Now please take note of one thing, that the complex number system is represented with a C written like this, while a real number system is written with this symbol R or this symbol R. Okay, so please take note, there are two number systems under numbers as a whole. And let's come over to the real number system. Under the real number system, if a number is real, it means that the number is either rational, represented with this type of Q. So rational number system is represented with this kind of Q, or the number is irrational. Now I'm going to be using this type of F to represent an irrational number system. Okay, so if a number is real, it is either rational or irrational. Now please take note of one thing. If a number is rational, it means that that number must have been an integer, and I'm going to be using this type of Z to represent an integer number system. And directly under the integer number system comes the numbers we call natural numbers, and I'm going to be using this type of N conventionally to represent the natural number system. Now remember, our topic says swords. Now it is important, like I said earlier on, to understand numbers briefly. This video is not dedicated to studying numbers. I'm going to be making a separate video for numbers, but please take note that for you to understand swords, you must know where we are coming from. Okay, so natural number systems fall under integer number system. Integer number system falls under rational number system, and rational number system together with irrational number system makes what we call the real number system. The real number system added to the complex number system or united with the complex number system makes what we call number systems altogether. So I'm going to tell you quickly what kind of numbers you find under the natural number system. The natural number system contains numbers we call whole numbers. Okay, numbers that are not fractional, numbers that are whole. Okay, and for the natural number system, we have two types of natural number system: the one we call N0 and the one we call N1. N1 is the natural number system that begins with 1. There are a group of mathematicians who believe that the natural number system starts with the number 1. So in that system, they believe that 0 is not a natural number. However, there is another group of mathematicians who believe that natural number system starts with 0. In other words, 0 is a natural number. Now, that is not the focus of this video. Please take note. So I believe that natural number systems start with 0. So 0 to me is a natural number. So I'm going to start with 0, 1, 2, and so on. So the kind of numbers you find in the natural number system are numbers that begin with 0, 1, 2, and so on. In other words, there are no fractions in the natural number system. Now you will take note of one thing, that in the natural number system, all the numbers that are found are positive and whole. But when you come over to the integer number system, the integer number system now accommodates numbers from minus infinity that are whole to plus infinity. In other words, I will have three ellipses, or the ellipses rather, comprising three dots going to minus 3, minus 2, minus 1, 0, 1, 2, 3, and so on. Okay, to plus infinity. So in what is called the integer number system, you have numbers that are whole, either negative, 0, or positive. Okay, now those are the kind of numbers you find in the integer number system. Sorry. Now in the rational number system, the kind of numbers you find are numbers that can be expressed as a ratio of two integers. Okay, so in this number system, whereas in the integer and natural number system there are no fractions, in this number system called the rational number system, represented with this type of Q, please take note that all numbers that can be expressed as a ratio of two integers such that b is not equal to 0 is accommodated here. It means that every natural number, certainly which can be expressed as a ratio of two integers, is a rational number, and every integer is also a rational number. However, there are numbers that cannot be expressed as a ratio of two integers. So if I call this number x, for instance, that x is a rational number, it means that x, whatsoever it is, can be expressed as a ratio of two integers. Why are natural numbers and integers also called rational number? It is because every natural number can be expressed as a ratio of two integers. For example, take 2 for instance, which is a natural number. 2 can be expressed as 4 over 2, it can be expressed as 8 over 4, and so on. If you take an integer such as -3 can be expressed as a ratio of two integers, which is -6 divided by 2, and you can even take -18 divided by 9, it will give you -18 divided by 6, it will give you -3. So it means that natural numbers and integers can be expressed as a ratio of two integers, therefore making them rational numbers. Okay, so every natural number, integer are also called rational numbers. Now, rational numbers in particular are fractional numbers. Okay, they can be expressed as a ratio of two integers. However, if x is a rational number and can be expressed as a ratio of two integers, it will be categorized under rational numbers. However, there are numbers that cannot be expressed as a ratio of two integers, meaning that there are numbers x that cannot be expressed as a ratio of two integers. Those kind of numbers are called irrational numbers. The focus of this video is not to dwell on numbers, it is just to give you a preamble that sets the pace for what we are going to be studying in what we call Surds as a topic. Okay, so you need to appreciate numbers to understand Surds. Now, this particular number system we call irrational number system has numbers like pi, it has numbers like square root of 2, it has so many numbers, even including the number we call the exponential. All these are examples of irrational numbers. They are numbers called irrational numbers simply because they cannot be expressed as a ratio of two integers. Take note, pi is an example of an irrational number, square root of 2 is an example of an irrational number, the exponential is an example of the irrational number. So these numbers are irrational because they cannot be expressed as a ratio of two integers. However, if you combine all the irrational numbers you know added to the rational numbers you know, they will make what we call the real numbers. So that being said, what then do we call Surds? Okay, now my definition starts this way. Surds are irrational numbers. Now, to start with, please take note, everybody, surds are irrational numbers. But the question is, are surds the only type of irrational numbers? Or what type of irrational numbers are surds? So the definition does not stop here. If you stop the definition here that surds are irrational numbers, you will be wrong. So surds are irrational numbers. The question is, what type of irrational numbers are they? Surds are irrational numbers that are formed by taking the roots of rational numbers. By taking the roots of rational numbers. So it means that in the rational number system, there are a group of in the irrational number system, there are a group of irrational numbers we call surds. So out of all these examples I gave you on irrational numbers, which ones do we categorize as surds? So surds are a type of irrational numbers. How are they formed? They are formed by taking the roots of rational numbers. Now, taking the roots of rational numbers will give you surds implies what, everybody? It implies that there are two types or two categories of surds. Now, let's go to types of surds. Okay, so if surds are irrational numbers formed by taking the roots of rational numbers, it gives rise to basically two types of surds. There are what we call we call them quadratic surds. Quadratic surds. And there are what we call B, we call them non-quadratic surds. Non-quadratic surds, or they are otherwise called higher degree surds. Okay, higher degree surds. So if surds are not quadratic, they are called higher degree or non-quadratic surds. Okay, that being said, let us now go over to what quadratic surds are. So if surds are irrational numbers formed by taking the roots of rational number, please take note of one thing. I said roots. Now please take note of this before we go into quadratic surds, that when we say surds are irrational numbers formed by taking the roots of rational numbers, it means that a number like this could be a surd. The square root of 2. Take note, the square root of 2 is a quadratic surd. A number like the cube root, of 5 would make for a surd. A number like the fourth root of 11 will make a surd. Okay, So these are examples of swords. However, the kind of swords we call quadratic swords are this type. Any sword that is formed by taking the square root of a rational number is called a quadratic sword. However, swords that are formed by taking higher roots, like the cube root, the fourth root of any rational number, are called non-quadratic swords or higher degree quadratic swords. So, simply put, quadratic swords are swords formed by taking the square root of rational numbers. But non-quadratic swords are swords formed by taking higher roots of rational numbers. Okay, so an example of a quadratic sword is the square root of 2. An example of non-quadratic swords are examples of non-quadratic swords are the cube root of 5, the fourth root of 11. Now, please take note, in this particular lecture, take note, our emphasis will be on quadratic swords. Thank you very much. Now let's go to the next thing I want to say in this video. The next thing I want us to deal with under this topic called, or this lecture called, swords, please take note, is the rules of swords. In studying swords, please take note that there are rules of swords. What are the rules of sword? Number one rule in swords says that when you take if you multiply two quadratic swords, root A times root B, the result you get is the same as taking the root of their product, that is the square root of A times B. The second rule of sword says that when you divide one quadratic sword by another quadratic sword, the result is the same as taking the root of their quotient. Okay, however, there is a third rule which is actually not a rule of sword, but it is considered a rule that students must observe, is that the square root of A plus or minus the square root of B is not equal to, and should not be perceived by any student to be equal to, the square root of A plus or minus B. So this is also considered a rule of sword, just like a remark for students to know that although 1 and 2 are applicable in swords, 3 is not applicable. Okay, now what this means for rule number 1, for instance, is that the square root of 6 times the square root of 4 is equal to the square root of 6 times 4. Now take a look at it. The square root of 4 is 2, and the square root, let's take something simpler. Let's put the square root of 9. Okay, so the square root of 9 times the square root of 4. The square root of 4 ordinarily gives you 2. The square root of 9 gives you 3. Okay, now compare your result of 3 times 2. 3 times 2 will give you 6. Let's compare this result with what we have here. So this other side of the equal to will tell us that the square root of 9 times 4 is the square root of 36. And guys, what is the square root of 36? It is 6, showing you that law number 1 is true. Now, if you take this example, if you use the same example to show that law number 2 is true, then what you would have is the square root of 9 divided by the square root of 4. What would it give you? The square root of 9 divided by the square root of 4 is 3 over 2. Now, let's compare. What if we took the square root of 9 over 4? The square root of 9 over 4 will be the same thing as 3 over 2. If you punch your calculator, you will see it is 1.5. Now, that tells you that law number 1 and law number 2 are both correct. However, if you try the same thing for law number 3, you will discover it is wrong. I would advise you to try that. That being said, for the rules of sword, now that we know the rules of sword, let us move on to the next thing. Okay, so the next thing I want to discuss under sword, this topic called sword, is what we call the basic form of a sword. Basic form of a sword. So what do we call the basic form of a sword? What do we call the basic form of a sword? Please, guys, take note that the basic form of a sword is the simplest form. It is the simplest form of the sword. Okay, so the basic form of a sword is the simplest form of the sword. Please take note, in this form we call the basic form of a surd. In this form, the rational number, in the basic form of a surd, the rational number under the square root, of course, since we are talking about quadratic root, the rational number under the square root symbol, contains no factor, which is the square of another number. Now I'm going to explain this. So in what we call the basic form of a surd, please take note. You know that a surd is formed by taking the square root. A quadratic surd in particular is formed by taking the square root of a rational number. Now, if the rational number under the square root is such that it contains no factor which is the square of another number, then that particular surd is called the basic form of the surd. Let me give you an example. Now, look at this. If I give you a surd like square root of 16, is square root of 16 in its basic form? The answer is a big no. It is not in its basic form. And why is that so? The number under the root is 16. You will notice that in 16 there are factors such as 4 and 4. Okay, now the factors such as 4 and 4 are the squares of 2 and 2. So if the number under the surd, under the square root, is such that it contains factors that are squares of another number, then that particular surd is not the basic form of a surd. Compare a number like 5. A number like 5 under the square root makes this surd in its basic form, simply because the number 5 does not contain any factor that is a square of another number. For example, the only factors of 5 are 5 and 1. Okay, now out of these two, 5 and 1, you will notice that none is the square of another number. 1 is a trivial case, so 1 squared will give you 1. But comparing 5 is not the square of any other number. So whereas 5 can be called the basic form of a surd, 16, the square root of 16, is not the basic form of a surd. Okay, it means that in the basic form of a surd, you cannot decompose the number under the square root into a product of two factors such that 1 is the root of another number, or the square of another number. Okay, so that is what we call the basic form of a surd. Now I will show you how to put certain surds in their basic form. If you are given a surd that is not in its basic form, it is actually simple to put those form, the surd in its basic form. So what I'm going to do is, let's call it example 1. Now, if we are given a surd such as square root of 32 and we are asked to put this surd in its basic form, look at square root of 32, you will know that it is not in its basic form, simply because square root of 32 can be decomposed into 16 times 2. Now, looking at 16 and 2 being factors of 32, you will notice that 16 is the square of a number 4. So it means that provided I can write 16 as 4 squared and times 2, it means that this 4 squared disqualifies 32, the square root of 32, as being in its basic form. So what you do when you are asked to put a number in its a surd in its basic form, you have to decompose and simplify. So what I'm going to do, step 1, is to write 32 under the square root as 16 times 2. Okay, a product of two factors of 32, such that one factor is the square of a number and the other factor is not. So 2 is not the square of any number, but 16 is the square of 4. So that gives me 4 squared. Now that would imply by the first rule of surd that this is 4 squared times square root of 2. And the square root of 4 squared will give you 4 times root 2, and my answer will be 4 root 2. Okay, now I could also reverse this process back to 32. So if I was given 4 root 2 and asked to, which is in the basic form, okay, 4 root 2 is a surd now in its basic form. If I was asked to put it as a normal surd, all I would have to do would be to incorporate 4 back into the square root, and for 4 to go into the square root, it has to come with a square times 2, and that will give me the square root of 16 times 2, which is equal to the square root of 32. So you can reverse the process. Let's take another example. Now, what if we were given 8? 8 is not in its basic form, simply because 8 can be written as the product of two numbers, 4 and 2, such that 2 is not the square of any number, but 4 is the square of another number. So I'm going to put here the square root of 4 times the square root of 2, which will give me 2 times root 2, which is equal to 2 root 2. Okay, so the surd I was given was not in its basic form, and by this process I've put it in its basic form. Now, what if I wanted to reverse the process back to 8. All I have to do is to start with 2 square root of 2, and I will bring these 2 outside into the square root by squaring it times 2, and that would mean the square root of 2 squared, which is 4, times 2, which will give me the square root of 8. Okay, so that is how simple it is to move from a sort that is not in its basic form to a sort that is in the basic form, and reverse the process also. It is that simple. Now, that being said, let us go to the next thing I want to talk about under sorts. There is a concept called similar sorts. Let us discuss it, guys. Similar sorts. So, when are sorts said to be similar? Similar sorts, we say, are sorts. Similar sorts are sorts that are multiples of the same sort. So 2 sorts are said to be similar when they are multiples of the same sort. For example, 2 root 3, 3 root 3, 4 root 3, etc. are similar sorts. Why are they similar? You will notice that the basic sort here is root 3. Now, 2 root 3 is a multiple, 3 root 3 is a multiple of root 3 as a sort. 2 root 3 also is a multiple. 4 root 3 is also a multiple of the basic sort, which is root 3. Similarly, you could have 20 and the root of 20 and the root of 45 are similar sorts. Why? It is simply because 20 can be written as the square root of 4 times 5, and 45 can be written as the square root of 9 times 5. 4 times 5 in square root means that you would end up having 2 root 5, and this would amount to 3 root 5. So if you look at it, 2 root 5 and 3 root 5 are similar sorts because they are multiples of the basic sort root 5. Okay, so similar sorts are multiples, are sorts that are multiples of the same sort. So please take note of that. Now, guys, why is it important to understand similar sorts? It is important to understand similar sorts because you can use them in simplifying problems in sorts. So let's look at an example. If you were asked to simplify a sort like this, the root of 20 plus the root of 45 plus the root of 25 of 125 minus the root of 2 root 80. Let's assume we're given a problem like this. How do you simplify it? You can simplify this kind of problem using the concept of similar sorts by making 20 2 root 5, by how we simplified it earlier on, and making this 3 root 5 added to 5 root 5. How do you do that? 125 is the same as the root of 25 times 5, and the root of 25 times 5 is 5, which is the root of 25 times root 5, and that will give you 5 root 5. If you do that to this, you would have the root of 16 times 5. 80 is 16 times 5, and that gives you 16 times 5, which will reduce to 2 times 4, which is the square root of 16 root 5. Okay, so this will give you 2 root 5 plus 3 root 5, which is 5 root 5, and 5 root 5 plus 5 root 5 will give you 10 root 5. So the problem simplifies to 10 root 5 minus 2 root 5. So that is 10 root 5 minus 2 times 4 root 5 rather will give you minus 8 root 5, and that simplifies to 3 root 5 as your final answer. So what I'm saying in essence is that you can use the concept of similar sorts to solve or simplify problems in sorts. That being said, let us go to another concept I want you to understand under sorts, and it is the concept we call conjugate sorts. Conjugate sorts. Okay? Conjugate sorts. Now, the conjugate of a sort is simply another sort which multiplies the sort you are given to give a rational number. So, please take note. 2 sorts are conjugates. 2 sorts are conjugate of one another if they multiply to give a rational number. So if 2 sorts which are irrational numbers multiply to give a rational number, then it means that each of them are conjugates of one another. So please take note of that. So let's see, for example, if we have root A plus root B, what will be the conjugate of root A plus root B? The conjugate of root A plus root B will be root A minus root B. So the conjugate, more or less, is formed by taking changing the sign from plus to minus. Okay, and why is root A minus root B the conjugate of root A plus root B? It is because when you multiply root A plus root B by root A minus root B, this amounts to the difference of two squares, root A squared minus root B squared, if you are familiar with the concept of difference of two squares. And that will give you root A squared will give you A, and root B squared will give you B. So root A plus root B multiplying root A minus root B gives a rational number A minus B. So when two surds are conjugate of one another, they multiply themselves to give a rational number. So let us see. What if I ask you to find the conjugate of 3 plus root 5? The conjugate of 3 plus root 5 will give you 3 minus root 5. And that is because 3 plus root 5, when it multiplies 3 minus root 5, will give you a rational number. Let's try it. This will be difference of two squares, 3 squared minus root 5 squared. And that will give you 9 minus root 5 squared, which is 5, giving you 4. And 4 is a rational number. So please take note of that.